Hello everyone, this is lesson 4.3, point slope form of a line. In this lesson, we're going to learn how to write equations in point slope form. So you should have already watched the video on Khan teaching you where the slope formula came from and the basics of how to use it. I think he just gave you one example. So we're going to take that and do a couple other examples, and I'll show you again the proof for the point slope formula. And that way you'll get some more confidence for your assignment. So it looks like this one is not letting me see. How about this one? All right, there we go. So here's a warm-up question before you start. So think about what you learned last Wednesday and Thursday or Friday, how to write equations in slope-intercept form, y equals mx plus b. So say you have an equation of a line that passes through the point 4,3 and has a slope of 2. Write the equation of the line. All right, pause the video and go ahead and try it using what you learned last week. All right, so remember that last week you learned that you need to substitute in x, y, and m into the equation because you're trying to solve for the y-intercept. You could also solve this with graphing by plotting the point 4, -3 and using the slope of 2 to get the y-intercept. So I'm going to try it both ways. So y is -3. I'm just going to substitute each of my values in. M is 2. X is 4 plus b. Simplify 2 and 4. Subtract the 8. And you get b is -11. Okay, I wonder if we even did a problem like this before. What if you solved it graphically? So plotted the point for -3. Yeah, maybe we didn't do this one. And then the slope of 2. No, maybe we did. I don't remember. But anyways, so the slope of 2 goes up 2 and over 1, but you're not going to be able to find the y-intercept by going up 2 and over 1 because you're getting further away from the y-intercept. One thing that another student said, and I liked how he said this, is that if your point already passed the y-intercept, then you're going to have to go backwards. So instead of going up 2 and right 1, you're going to go down 2 and left 1, down 2 and left 1. Keep doing that, and then you'll reach -11, where it will hit the y-intercept. So then your equation is y equals 2x minus 11. All right, so now we have a new way of doing this. So we're going to take a different problem. So consider the line that goes through the point 2, 3 with a slope of 1/2. So we're going to discover the point slope form. Whenever I prove a formula to you, you don't have to remember how to prove it. It's just good to watch and take note so that you just know where it comes from. All right, so let's set up the slope formula, and let's say that the slope is 1/2, and then I'm going to do the slope formula between 2, 3, and xy. So I'm going to say y2 minus y1 equals x2 minus x1. All right, and now I'm going to cross multiply. So we're going to have 1 times x minus 2. So 1 times x minus 2 equals y minus 2. Actually, hold on a second. I'm only going to cross multiply halfway. I'm sorry. One thing that we can do, instead of cross multiplying both ways, is just multiply both sides by the denominator of x minus 2 times x minus 2. So then on this side, we'll have 1/2 times x minus 2. And then x minus 2's over here will cancel. So you can put this over 1. And then we'll have y minus 3. Now I'm going to just flip both sides of the equation around. And this is actually your point slope form of a line. So the point slope form of a line says y minus y1 equals m times x minus x1, where your point is x1, comma y1, and in our case it was 3, comma 2, and then the slope was 1/2. Now, the most important thing to notice is that in the form, in this form, which you should write in your notes, y minus y1 equals m times x minus x1, in the form there are subtraction signs. So if your point has negative numbers, say -3 and -2, then if you plugged negative in for x, it would be x minus -3, and that would turn into +3. So if ever you see x plus 2 equals 1/2 x plus 3, that means that the 3 and 2 are actually negative in the point. Okay, if they're minus, then the points are just the numbers as is, so 2 and 3. Okay, so one thing to notice that the numbers in for x and y are opposite of what they look like in the equation. So let's do a few examples. And this is just another reiteration of your point slope form. So here's an easy warm-up question. So let's take our warm-up question, which was 4 comma -3, and then the slope was 2. And let's write it in point slope form. So we'll do y minus y1, which would be y plus 3, equals 2 times x minus x1, which is 4. That's the equation in point slope form. And then part B passes through the point, -1, 4, has a slope of 2. So this would be y minus 4 equals -2 times x plus 1, since the 1 is negative. All right, so kind of the same thing as we keep going. So part C, -3, 1 has a slope of 3. Y minus 1 equals 3 times x plus 2. 3. And then if you're not given the slope, then you would have to find it. So 8 minus 2 over 1 plus 2, which would be 6 over 3, which is 2. And then the question is, which point do you use? Well, it'll always tell you in the problem, but I don't know, I'll just use this one. It really doesn't matter, but make sure you read the problem. It'll tell you which one to use. So there's one option, and then there's the other equation. Okay, if you graph them, they would be the same thing. It's just they go through a different point. All right, and then another type of example is if you are given the equation and you want to graph it. So what you would have to do is identify the slope and the point. So here, the point would be 3, -2, because remember it's the opposite sign. Here the slope would be 2, 1. Here the slope would be -2 and 2. So what you would want to do is plot the point and then use the slope to get another point. So we would be 3, -2, and then our slope is 2/3, so we would go up to over 3 to get another point. And then you would just keep doing that, okay? I'm not going to show the other two just to save you some time. And then a third example is, what if we have a graph? So what would we do in this case? Well, let's say we'll use the point to the left, and first we need to identify the slope. And in this case, you're going down to and over 2. So that means -2 over 2 is -1, or you can even do down 1 over 1. So then the equation in point slope form would be y minus 3 equals a -1, and then x plus 1, because we have the opposite sign. All right, and then here, now notice how the y-intercept is not shown here on the graph. So, well, anyways, we would have to use the slope. You could subtract the values or do rise over run. So here we would have -2, and then over 1, 2, 3, 4. So the slope would be -2/4, which is -1/2. And then let's use this point here. So y minus 2 equals -1/2 x plus 1, right? And let's do another word problem, because I know word problems were tricky on our last assignment. So it says from 1990 to 2001 in Boston, Massachusetts, the annual excess fuel in gallons per person consumed due to traffic delays increased by 1.4 gallons per person each year. That would mean that this number represents the slope of the problem. So M is 1.4 gallons per person per year. Okay, so if it's 1990, that represents x equals 0. 2001 represents x equals 11. So 1995 represents x equals 5, and then consumed about 37 gallons of excess fuel. That represents the y coordinate when x is 5. All right, so just like the other examples, the first sentence gives you the slope of the situation. The next sentence gives you a point in time. And then write the equation that gives the annual excess fuel as a function of the number of years since 1990. Okay, so here we have slope and we have a point. So using the point slope form of the line is the perfect equation to use for this example. So let's go ahead and write it in point slope form. So we would do y minus 37 equals 1.4 and then x minus 5. Let's say now that it actually wants us to put it in slope-intercept form, which is y equals mx plus b. Okay, all you would need to do is just convert it into slope-intercept form, which is actually not that hard. So the first thing you would want to do is get rid of the parentheses by distributing the 1.4. So you would still have y minus 37 over here, 1.4x, and then minus, what would this be? I want to say 6. Let me just double check here. So this would be 20, or maybe it's 7, 5, 6, 7. Yeah, 7. And then add the 37 over. So this would be y equals 1.4x and then plus 30. Okay, so that would mean if the y-intercept was 30, that in 1990 there were 30 gallons, or whatever this is, 30 gallons per person each year. Okay, so it doesn't matter which form you write it in. You can leave it in slope-intercept form if it doesn't specify otherwise, or you can convert it into slope-intercept form if it does. All right. Let's look at another example for a word problem. The table shows the costs of visiting a working ranch for one day and night for different numbers of people. Can this situation be modeled by a linear equation? Okay, so if it wants to know whether it can be a model by a linear equation, the key thing you want to know is there a constant slope? So here we're increasing by 2 each time. So are we increasing here the same? So you're going up by 100, up by 100, up by 100, up by 100. So this would be yes. And then you could say because it is increasing by a constant amount. Which would be so 100 per 2 people or 50 per person. So 50 per person. Okay, so that is the end of these examples. And next, you will go ahead into the Elastic assignment for today. And don't forget that you also have an additional video to watch before tomorrow's assignment on converting between slope-intercept form, standard form, and point slope form of line. All right, I hope you have a great day.